The unsung heroes in the war on crime are the scientists and technicians in the laboratories of the Bureau of Alcohol, Tobacco, and Firearms. They are the scientific super sleuths who team with special agents to enforce federal laws concerning firearms, explosives, alcohol, and wagering. The work of ATF scientific crime fighters is performed both for Bureau agents and any requesting law enforcement agency. The ATF Identification Laboratory is concerned with the examination of fingerprints, voices, inks, bullets, firearms, and handwriting in the study of suspect documents. The authentication of documents often plays a vital role in criminal cases. Through the efforts of ATF personnel, the Bureau has established the world's largest ink library with more than 3,000 brand samples. By analyzing inks, it is possible to determine if signatures have been altered or backdated. Many felons attempt to falsify the ATF firearms transaction forms, which must be completed before purchasing a gun from a federally licensed firearms dealer. For analysis, a sample of dried ink the size of a pinprick is punched from the form. The samples are placed in a solution and examined by thin layer chromatography, which separates the ink's components. This results in a chemical fingerprint of the ink. The process is performed twice, once for screening, and the second time to permit closer comparison with one of the standard reference inks. The ultraviolet characteristics of ink further refine the identification, and the use of infrared light permits the examiner to determine if writing has been altered.
Hello, Mrs. Smith. It's me again.
In its efforts to seek the most modern methods of fighting crime, the Bureau of Alcohol, Tobacco, and Firearms was one of the first law enforcement agencies to experiment with and refine the use of voice print analysis. The theory is that no two voices make the same sound. These vocal sounds are recorded and interpreted as highs and lows on a voice print spectrogram.
There's a bomb going off at 5 o'clock. There's a bomb going off at 5 o'clock. There's a bomb going off at 5 o'clock.
The questioned voice is compared to a known voice by using the voice graphs. The skilled voice print specialist then is able to interpret the spectrograms and determine if it is or is not the same speaker. Guns suspected of being used in a crime are test-fired to obtain comparison bullets. While there are many types of bullet recovery chambers, ATF uses one in which the bullet is fired through a piece of space-age rubber into a tank of water. The rubber seal is a material developed by NASA for use in the space program to maintain pressure inside rockets and spacecraft. The bullet is fired into the rubber, which expands as the bullet passes through and then closes behind it. This permits a virtually unmarred test bullet to be recovered from the water for comparison with the crime bullet. The comparison of bullets is done under a powerful microscope, where it is possible to see the marks and striations caused by the gun barrel of the weapon used. Firearms examiners attempt to raise obliterated serial numbers, compare bullets, or inspect guns for other markings which could aid in establishing someone's guilt or innocence. In the case of obliterated serial numbers, it often is possible to make them visible by placing acid on the metal. Sometimes the use of low voltage current speeds the action of the acid on the metal. In the investigation of criminal bombings, ATF scientists often must perform an analysis of metals in the bomb. This is done with an emission spectrograph. the metal sample is vaporized and the emitted light is separated into characteristic wavelengths for identification. The metal may match a piece of pipe taken from a suspect's home, and this becomes a piece of evidence. These pieces of pipe, found on a convict who was a prison plumber, were sent to the ATF laboratory for examination. This pipe really is an ingenious gun, wadded like a blunderbuss, loaded with solder droppings, and detonated by screwing the faucet handle onto tightly packed match heads in a firing chamber. The investigation of arson has burgeoned as a spin-off challenge for the laboratory staff. To detect arson, the forensic scientist searches for some trace of an accelerant, some substance which might have been used to start or help spread a fire. Such evidence is sealed in containers and sent to the laboratory, where the scientist withdraws a sample of the vapors for examination by gas chromatography. In this case, the wick of a Molotov cocktail was sent to the lab for examination. The lab has its own mechanical bloodhound in this explosive sniffer, which is a vapor trace analyzer. The sniffer can detect minute traces of dynamite as well as other explosives. Nevertheless, ATF scientists are constantly seeking a better and cheaper way to determine the presence of explosives and a way to trace them after detonation. To answer the classic crime question of who fired a gun, ATF scientists have developed new, improved instrumental techniques to show gunshot residue using flameless atomic absorption. The investigator must quickly take swab samples from the hands of the suspect in the search for the residues, which are the elements barium and antimony. Each swab sample is treated with nitric acid. The liquid sample then is atomized by heating to very high temperatures, and the combined chemical elements are broken down into component atoms. Before atomization, the sample swab is placed on a strip of tantalum metal ribbon, which is heated. The sample is vaporized and alakazam. The elements are broken into atoms in the light path. These new methods can detect the presence of barium and antimony in imperceptible amounts equal to 1 part in 10 million. It may seem a long way from a backwoods moonshine still to the modern methods of the ATF laboratory and its sophisticated equipment. But in today's fast-paced world, the journey for a moonshine sample can be swift and decisive. While some consider moonshining a folk art, the manufacture of illicit whiskey, or moonshine as is commonly known, has been a serious problem in the United States. The making of moonshine is confined mainly to the southeastern states, but much of this illicit whiskey contains deadly impurities, which are a danger to health and even life. Moonshine represents a considerable tax fraud to the government, since legal distilled spirits are the nation's highest taxed product. While the methods and locations of moonshiners are often crude and primitive, ATF scientists use the most modern methods to help catch and convict these criminals. Moonshine analysis is done at the ATF headquarters lab using the neutron activation process. The moonshine sample first is sent to the Bureau of Standards, where it is irradiated. In the ATF lab, the sample is examined with a gamma-ray spectrometer. This is actually a series of instruments which make up the neutron activation analysis equipment. The radioactive moonshine sample is placed behind a lead shield, also called a cave, where sensitive crystals detect the gamma radiation. This radiation is displayed as blips of light so that the elements of the sample can be determined. These sophisticated methods have helped to bring convictions and thus diminish the incidence of moonshining. The use of applied science in fighting crime requires an in-depth knowledge of laboratory technology and considerable inventiveness, factors which ATF scientists and technologists possess. This makes the ATF scientist a vital member of the criminal investigation team. Together, the scientist and the investigator seek to make America a safer place in which to live.